Another score to represent location. When discussing the empirical rule or Chebyshev's rule, details applied when values were exactly 1, 2, or 3 standard deviations above or below the mean. Suppose we are interested in a variable, call it x, which has a distribution with a mean of mu and a standard deviation sigma. X will be the value of some measured characteristic of interest. We begin by transforming from the given value or values of interest into z-scores. This is simply a change of scale, like inches to feet. A z-score represents how many standard deviations above or below the mean or raw score is located. In the empirical rule, the location mu minus 1 sigma is 1 standard deviation below the mean, so as a z-score, this is negative 1.00. Similarly, the location of mu plus 2 sigma is 2 standard deviations above the mean, so as a z-score, this is positive 2.00. We can actually use any value and find a z-score with a simple formula involving subtraction and division. A z-score is calculated as z equals x minus mu over sigma, or value minus mean divided by standard deviation. A positive z-score means the value of x is above the mean. A negative z-score means the value of x is below the mean. A z-score of 0 means the value of x is equal to the mean mu. Notice that the population mean mu is always subtracted from the other value of interest in the numerator of a z-score. Suppose the monthly utility bill for residents in the area during June follows a normal distribution with a mean of $100 and a standard deviation of $15. Find and interpret the z-score for a bill of A, $80, B, $133. For $80, the z-score is calculated as 80 minus 100, with that result divided by 15 to give negative 1.33. For $133, the z-score is calculated as 133 minus 100, with that answer divided by 15 to give 2.20. A bill of $80 is 1.33 standard deviations below the mean utility bill amount. A bill of $133 is 2.20 standard deviations above the mean utility bill amount. Z-scores comparing scales. Another use of z-scores can be to compare values from different groups or locations or scales. Suppose we want to compare two students who went to different high schools. Suppose Jim went to North High School, where the mean GPA is 3.12 and the standard deviation is 0.28. Susan went to South High School, where the mean GPA is 2.88 and the standard deviation is 0.36. Jim graduated with a 3.26 GPA, while Susan only graduated with a 3.15. Relative to other graduates from their schools, who has the better GPA? Since the schools differ in scale, you can't directly compare, so let's calculate z-scores. Recall the information indicates that Jim went to North High School, where the mean is 3.12, the standard deviation is 0.28, and his GPA was 3.26. Susan went to South High School where the mean GPA is 2.88, the standard deviation is 0.36, and her GPA is 3.15. Jim's z-score is found as 3.26 minus 3.12, which gives 0.14, which is divided by 0.28 to give 0.50, or 1/2. Susan's z-score is 3.15 minus 2.88, which gives 0.27, which is then divided by 0.36 to give 0.75. Jim's GPA of 3.26 is 0.5 standard deviations above the mean GPA at North High School. Susan's GPA of 3.15 is 0.75 standard deviations above the mean GPA at South High School. Susan is farther above the mean, so she performed better.